All right, before we get started, let's do a few things. Let's silence our phones. But while you're touching your phone, remember that the ARC does have an application for this forum. It has a polling function in there, so we'd appreciate if you could give this session the highest rating, if you think it's deserving of that. You can also tweet about this using the hashtag ARCforum. And all of our information in the Smart City effort here does get distributed on the Twitter account @ smartcityvwpts.com for Smart City Viewpoints. So without further ado, let's get started. So some of you may know that the Smart City effort here at ARC is a beginning effort. I'm Jim Frazer, and I came on in October, and I lead this initiative. Eddie Fiddler is one of our newer analysts. He's been here longer than me, so he's no longer new. But he focuses on transportation and smart cities. We've got Eakin Jacob, who focus on smart buildings and building automation. Larry O'Brien, some of you know, he's a senior member of ARC, and he is our cybersecurity guy. Alex Chatta focuses on smart buildings, platforms, smart cities, and lighting. Rick Rish knows everything you wanted to know about energy, microgrids, photovoltaics, PV, you name it, automated demand response. Wasey has joined us recently in Munich, and he is our smart rail and rail transportation analyst. And in the back of the room, last but certainly not least, is Rob D'Angelo, our director of sales. So we've got really a very powerful series of sessions this week. We're about halfway through, but tomorrow we have the cybersecurity challenge for smart cities. We have Rick is running a session on drones for smart cities and industry. I'll be leading a mobility as a service platform session 8:30 on Thursday morning. And if you're lucky, you might be able to get a ride on an electric scooter in that session. And Eddie is winding up the Thursday with smart parking systems, dramatic impacts, and current challenges. And if we're lucky, there may even be a tour at the end of the week as well to Florida's SunTrax testbed. So what is driving smart city best practices? Well, increasing urbanization. Many people around the world are moving into cities. Rural areas are suffering as a result, but also there's huge and not always positive impacts of all those people going to urban areas. Decaying infrastructure, not only in the United States, but we'll use that test case. Roads were built 50 years ago. Every 10 years, they're 10 years older. Maintenance issues are becoming very severe. Copper conductors might have been put out there to power streetlights 40, 50, 60 years ago. The insulation was not designed to go that long. So there's a lot of these hidden issues that continue to crop up. Financial pressures for new solutions. The expectations of the community, of citizens and other stakeholders has evolved over time, so that what was provided 30, 40, 50, or even 10 years ago doesn't necessarily fit where we are today. And sustainability. We didn't really talk about that 10 or 15 years ago, but sustainability has three pillars: preserving and enhancing the natural environment, preserving and enhancing human quality of life, safety, jobs. But while doing so, using the third pillar, which is economic or reasonable economic impact, meaning it has to have a reasonable, relatively short payback time and be financially feasible, or it's not going to get done, and you won't achieve your goal of satisfying pillars number 1 and 2. So I'm borrowing this graphic. I think it's a very powerful graphic, and it helps to define really what is a smart city. Because like smart grid or smart anything, that's quite an ambiguous term that's prone to many different and somewhat fuzzy, ambiguous definitions. So this graphic comes by way of the Smart Cities Council, And across the top are the generally accepted 9 applications that comprise a smart city. So there's the built infrastructure of buildings, firehouses, schools. There's the energy infrastructure. Many cities own their own distribution from substations on down, including streetlights and meters. There's the telecom network. There's the transportation network. That may be the city bus line, light rail, or other modes of transportation. Of course, water and wastewater are important. Health and human services. Very often there are community-owned or public agency-owned hospitals and urgent care centers. Public safety includes not only the safety of the crosswalk, but also the first responders and body cams and all the technology related to that. Payments and finance might not seem to be a smart city application, but online bill payment among all of these is probably the lowest hanging fruit in terms of quick payback. It's relatively easy to do, and it eliminates a lot of labor hours that don't need to be spent there. It can be spent more wisely somewhere else. And of course, waste management, including other technology or related technologies of waste to methane and all those technologies. So those are the applications. But in this IoT and digitally transforming world of ours, there's, I'm ahead. Across the rows across list, and let me see if this, in the rows, there are 7 technologies that impact those 9 applications. So you can see from this graphic, they're listed as instrumentation and control, connectivity, interoperability, and that's one we'll talk about with the panel. But interoperability is important because you want part A to work with part B. And if they do plug together, like your USB mouse, it drives commoditization, prices fall, there's more vendors, it's on the shelf down the street. There's just a lot of benefits to interoperability. Security and privacy. So we'll talk a little bit about cybersecurity, but on the other hand, there's also the increasing concern about privacy itself and where does our personal data go. Data management. With all these IoT devices in a smart city, there's a lot of data. Well, you can't just put it into one bucket somewhere, and it does need to be managed in a reasonable way. Next, number 6 is computing resources. Once you have that repository of data, well, you're going to need a machine to process it so that you create, number 7, some business intelligence using analytics. So what trends do we see in smart city best practices? Well, planning is becoming a larger and larger issue. In fact, there's some philosophies out there of Smart City 1.0 was vendor driven, that the vendors would come in and suggest that, hey, I've got the greatest technology ever, and this will do everything you ever wanted. Well, in some cases that's true, but in other cases it doesn't exactly fit the needs of the community and all the stakeholder community needs. So that was somewhat superseded in some of the published literature by what's become known as Smart City 2.0, which is the actual public agency or city administration itself defining what should be done and then going out to suppliers and vendors and contractors and doing it. But that too it's been recognized that too has its shortcomings in that some people were left out of that dialogue. So a number of people, including a professor from Dr. Boyd Cohen from Spain, defined Smart City 3.0. That really is a comprehensive look, an outreach to all your stakeholder communities, whether it be the bicyclist community, to the local business organizations in town, to public works workers, outside contractors, so that everyone has a place at the table, so that no needs are left unmet. Standards are beginning to be developed in that area, and I'll talk about them in one of my last slides here. One standard in particular that's being developed is the IEEE Smart P2784 Smart City Planning and Technology Guide. It's in its draft phase at present, but it's intended to be the umbrella standard for all IEEE, as well as other standards that impact that smart city planning and technology selection process. There's also what I'm quite fond of, the US DOT systems engineering process, which we'll have a graphic in a second. The other trend that is tough to get all of our collective arms around is that technology advances are occurring so rapidly. Well, 6 months is a long time, and that very often is much shorter than even than the annual requisition time of a public agency. So, what's the future for smart city best practices? This is probably the first time I've shown this graphic to the ARC audience, but we're going to see it again and again. So this is a representation of the V or waterfall model that some of you computer science people may have seen in the past. From the left, on the left side of the graphic, it represents your project conception. And you'll notice way to the right, you see operations and maintenance, followed by changes and upgrades, and retirement replacement. So this is a life cycle, represents the life cycle of the entire project that you're contemplating. The first step, this actually comes from the US Department of Transportation. It's their version of that generally accepted process. The first step is stakeholder outreach and documentation of consensus-based user needs. So define your stakeholder communities. That's the taxpayers, maybe commuters that drive through town, maintenance contractors that work on different systems of the town, or the traffic signals of the wastewater treatment plant, outside, the garbage haulers, elected officials. Cast a very broad net, and you might get 20 or 30 different sets of stakeholders that you would then go and query them for their needs. Once you have those needs, well, you do some of your own intelligent review of it and see which ones have consensus, which ones seem to be supported by many of those communities where there's not, where there's a genuine interest in moving ahead with them. So that's step one, user needs. And if you look, and I apologize, I know the graphic is a little small, but you start with a concept exploration, concept of operations, and you refine it from user needs to systems requirements. So on the left side, going down the V, it's user needs. Then you refine those user needs into measurable functional requirements. And on the right side, you go back up the V, refining those user needs to measurable functional requirements that can become a formal and unambiguous project specification. And along the way, you have test plans so that you don't deviate in your goal of satisfying those consensus-based needs, but also so that you don't allow the inclusion of any extraneous requirements that might have snuck in. So this is the way the US DOT does it, and in larger sense, the computer science community. If you do this, and it's on any road down to even a county road, you are eligible for 50% contributions from the U.S. Department of Transportation, from all of our gas taxes. So that's what we tend to see at IRC in terms of a tightly defined planning process for smart cities. This also benefits suppliers because they know exactly what they need to provide. They don't need to make a Swiss Army knife of every possible widget and gadget and say yes to every request. If you do this up front, you have a much better definition of what it is you really need to make. So with that, we won't move on to questions. We're going to move on to Joachim.